Welcome to Engineering Out Loud. We're back with the third deep dive in our series, from MECHESOL's MESP Engineering Development Program.
This one's all about concept development.
If you're digging these deep dives and want to go even deeper, definitely check out the program at mechesolco.com/CPD.
You can really level up your engineering game with that.
Okay, so concept development. It's where those brilliant ideas in design engineering,
You know, the light bulb moments.
exactly,
Mm-hmm.
become actual real-world solutions.
It really is the heart of the whole design process, wouldn't you say?
Absolutely. And that's what we're going to unpack today. So first things first, our sources talk about all these cool brainstorming techniques for generating ideas,
Oh, yeah, there are tons of them.
like basic functional brainstorming. Have you ever used that one?
All the time. It's a classic for a reason.
It really is.
Mm-hmm.
And mind mapping, I find that one super helpful for visualizing connections between different ideas.
It's great for seeing the big picture, for sure.
Then there's simple CAD sketching, which is great for quickly getting ideas down.
Even if you're not a CAD expert, just being able to sketch out rough concepts can be so helpful.
Totally agree. And then taking it a step further, there's building physical models and prototypes.
Getting your hands dirty. There's nothing quite like holding a physical representation of your idea.
It really brings the concept to life, doesn't it?
It does, and it helps you identify potential problems early on.
Totally. And speaking of learning from others, our sources also emphasize learning from existing products.
Oh yeah, that's a big one. There's no need to reinvent the wheel every time.
Right. See what's out there, what works, what doesn't.
And then there's the power of cross-disciplinary discussions.
Bringing in perspectives from outside your own little engineering bubble.
Exactly. I once worked on a project where we were totally stuck on a design problem.
Oh, tell me about it. I feel like that happens all the time in engineering. What did you do?
We ended up chatting with a colleague from the marketing team just to get their take on things.
Yeah.
They threw out this totally off-the-wall idea.
No way.
We all kind of laughed at first, but then...
Wait, don't tell me.
Oh.
It ended up being the solution.
It did. It completely changed our approach and led to a breakthrough.
That's amazing. It just goes to show sometimes the best ideas come from the most unexpected places.
You never know where that next game-changing idea will come from.
Exactly. Okay, so we've got all these amazing ideas swirling around, but here's the thing, and our sources are very clear about this. We can't just run with the first cool idea that pops into our heads.
We've got to make sure it's actually feasible.
Right. And not just feasible in some vague sense, but specifically looking at it from a technical, economic, legal, and operational perspective.
You got to cover all the bases.
So let's break that down. Technical feasibility, that's like, can we actually build it?
With the technology and materials available to us.
And there's economic feasibility. Can we afford to build it?
Will it be profitable or at least sustainable?
And then legal feasibility. Is it legal to build it? Are there any regulations or restrictions we need to consider?
You don't want to get caught out on that one.
And finally, operational feasibility. Will it actually work once it's built?
Will it be reliable? Will it be easy to maintain?
It's like we could come up with the most amazing concept for, I don't know, a flying car.
That's a classic.
But if the battery technology just isn't there yet to support the weight and the range we need,
Or if the materials we need are so rare and expensive that it cost a fortune to build, then it's back to the drawing board.
totally. It's a reality check, but a super important one. And once we've assessed feasibility, the next step is concept validation, right?
Sure.
And our sources list a whole bunch of techniques for this, like, well, there's a lot here.
There are quite a few, but they all have their place.
There's proof of concept, which I guess is kind of a general term for showing that the idea is actually possible.
It's about demonstrating that the core concept works.
Then there's data analysis, using data to support our decisions.
You gotta love some good data.
Then there's simulation and analysis, which can be super powerful for predicting how the concept will perform in the real world.
Virtual prototyping can save so much time and money.
And usability and ergonomics, which focuses on the user experience.
Making sure it's intuitive, comfortable, and safe to use.
That's something I'm always fascinated by. Can you give us a real-world example of how ergonomics plays out in concept development?
Sure. Let's say you're designing a new power tool, like a drill or a saw.
Okay, I can picture that.
You could pack it with all the latest tech, make it super powerful and efficient.
Sounds awesome.
But if it's awkward to hold, if the grip is uncomfortable, or if the buttons are in weird places...
Or if it's just too heavy to use for extended periods?
Exactly. Then it's going to be a flop. No one wants to use a tool that gives them hand cramps or makes their job harder.
Right. And that's where ergonomic testing comes in. You'd be looking at things like grip design, button placement, weight distribution,
And the overall feel of the tool in the user's hand?
making sure it's comfortable and intuitive to use.
You want it to feel like an extension of their own hand.
That makes so much sense. And it could even have safety implications, right? If a tool is uncomfortable or difficult to use, it could increase the risk of accidents.
Absolutely. Safety should always be a top priority.
If you're loving this deep dive into concept development, don't forget to check out the MESP Engineering Development Program at mechesolco.com/CPD. It's a game changer.
It really is.
Okay, so we brainstormed a bunch of ideas, weeded out the ones that aren't feasible, and validated the promising ones. Now comes the hard part.
Choosing the winner.
Right. We got to pick the best concept. And our sources give us 7 key considerations to guide this decision-making process.
They're like a roadmap for choosing the right path.
Okay, so first up, evaluation criteria definition. Basically, we need to figure out what best actually means for this particular project.
What are the most important factors we need to consider?
Then we've got comparative analysis, where we compare the different concepts side by side.
Weighing the pros and cons of each one.
And of course, we need to revisit feasibility and risk analysis.
Making sure the chosen concept is still realistic and manageable.
And then, a big one, stakeholder considerations.
This is where we think about the needs and perspectives of everyone involved.
Like the users, the manufacturers, the investor.
The engineers, the designers, the marketing team.
Everyone. We also have to look at the prototype testing results.
How did each concept perform in real-world testing?
And of course, compliance with standards. We need to make sure our chosen concept meets all the relevant regulations and industry standards.
You don't want to get to the end of the process and realize you've overlooked a critical requirement.
Totally. And finally, it all comes down to a robust decision-making process.
A clear and structured approach to weighing all the evidence and making the final call.
So it's not just about picking the coolest or most innovative concept.
It's about finding the concept that best meets the needs of everyone involved, while also being feasible, safe, and compliant.
It's like finding that sweet spot where innovation and practicality intersect. So there you have it, folks. We've covered a lot of ground today. We started by exploring the power of brainstorming to generate those initial sparks of brilliance.
Remember mind mapping.
And those crazy cross-disciplinary discussions that can lead to unexpected breakthroughs.
And don't forget about building prototypes.
Then we dove into the importance of feasibility and validation, making sure those great ideas are actually grounded in reality. We talked about technical, economic, legal, and operational considerations.
And all those validation techniques like ergonomics and user testing.
We even touched on the importance of stakeholder considerations in the concept selection process. So as you embark on your next engineering journey, remember that a well-defined, thoroughly vetted concept is the foundation for a truly successful design. And if you want to level up your concept development skills even further, head over to mechesolco.com/CPD and check out the MESP Engineering Development Program.
It's an amazing resource.
It is. All right, that's all the time we have for today. Thanks for joining us on Engineering Out Loud.
Until next time.